Please subscribe, like and watch. Thank you.
Welcome back. Problem 7.95. So the statement is that the cast aluminum rod shown is made of steel and alloy for which sigma ut is 70 megapascal and sigma uc is 175 megapascal. Knowing that the magnitude T of the applied torque is slowly increased and using Mohr criteria determine the shearing stress T naught that should be expected as rupture. So you can see this is the alloy rod, cast aluminum rod that is made up of alloy and is subjected to torque T, and due to this torque T there is shear stress that is generated. So this from this given state of stress we will write our given data. So in given data you can see sigma x is not available, so it will be 0. Similarly sigma y is not available, that is also 0, and tau of xy which is given here as T naught, and this will be minus. Why this is minus? So again for that you have to go back to the previous problems for stress transformation, so you will be easily understand why this is, when this will be positive and when this will be negative. So we have to find this T naught, clear, T naught for expected rupture, clear, but using Mohr criteria again. So let's start with the solution again. So you know that we will need principal stresses, that is sigma A and sigma B, for applying Mohr criteria. So sigma A is equal to sigma average plus R and sigma B is equal to sigma average minus R. Clear? Now sigma average is equal to 0 because there is you know that sigma average is equal to sigma x sigma y divided by 2. Both sigma x and sigma y's are 0, so sigma average is equal to 0. Clear? And R will be equal to sigma x minus sigma y divided by 2 whole square plus tau of xy whole square under the root. So sigma x and sigma y will be 0, so this term will be equal to 0, so R will be equal to under root tau of xy, and tau of xy is equal to minus tau naught square. Clear? And that will be equal to, if you take a positive value, so again this will be equal to tau naught or tau of xy. Clear? Now you can see that sigma average is equal to 0, so sigma A is equal to R and sigma average is equal to 0, sigma equal to minus R. Clear? And this sigma average is again, this is 0, so it means 0 means there will be no value. So sigma so this sigma A will be a positive value, clear, and sigma B will be a negative value. And if you draw the envelope for Mohr criteria, again I will not draw it as per scale. Let me show. Let's say this is your sigma ut over here. This point is sigma ut, clear, and let's say this point is your sigma uc again. So if I join this line in this line, so it will meet at this point. This horizontal axis is for sigma A and this vertical axis is for sigma B. Similarly, if you join these two lines by points, and if you join these 2 points, this will be your envelope. Clear? So you can see this sigma A and sigma B lies in 4th quadrant. So equation for fourth quadrant, equation for fourth quadrant will be sigma A over sigma ut minus sigma B over sigma uc, that is equal to 1. Again, this equation represent this line. Clear? So this line. Clear? If this value on the left side is less than 1, so means the points will be somewhere this. Clear? Clear? So if it is greater than 1, so the point will be here. But this equation represent purely this line. So this line means that this is the boundary wall, so maybe there may be rupture that is expected. So we will put the value of sigma A and sigma B. So sigma A is equal to R and sigma ut is 70 minus sigma B is equal to minus R divided by sigma uc is 175. That should be equal to 1. Clear? So again, there is R is common in between these two. So this will be 1 over 70 plus 1 over 75, and R is common, so that is taken out. It should be equal to 1. So if you solve this, so R will be equal to 50 megapascal. Now you have seen that R is equal to 50 megapascal and R is equal to tau naught. So R is equal to tau naught. So that will be equal to 50 megapascal. Clear? Again, you can see that when you put this value of R and minus R are the value of sigma A and sigma B in the envelope that is made as that you will made as per scale. So you will find that this point will lie on this line, which states that it is expected to fail under the shear stress of 50 megapascal. I hope you have learned from this video. Thank you for watching, and kindly subscribe my channel if you haven't, and share it with your friend as well. Thank you.